The concept of significant figures basically allows scientists to agree that when they write down a number, how accurate the measurement is. The number of significant figures actually indicates how meaningful a measurement is. Those with lots and lots of significant figures are more accurate. Those with only a couple significant figures are not as accurate. A couple quick notes. The number 1003, written like I have, 1003, supposedly has 4 places of accuracy. The 1 is showing the number of thousands, the 0 is showing the number of hundreds, another 0 is showing the number of tens, and the 3 is showing the number of ones. The concept is if the 1 is showing an accurate place and the 3 is showing an accurate place, then obviously the zeros in between must also be accurate. So this should have 4 places of accuracy, illustrating, supposedly, idea number 1. Second rule has to do with zeros to the left. And although this is a very simple concept, this is the one that most people screw up. Like obviously if you have the number 12, it only has 2 places of accuracy. If you put a 0 in front of it, you're not improving the accuracy. It still only has 2 places of accuracy. More zeros to the left are not improving the accuracy. Actually, they're just a waste of time. It's still the number 12 measured to the nearest tens and measured to the nearest ones, 2 significant figures. So anytime there are zeros to the left, they are not significant. Even when you see a decimal like 0.0005, this number only has 1 place of accuracy, and that's the 5. The zeros to the left of the number are basically just holding place. This number could easily be rewritten in scientific notation as 5 times 10 to the minus 4th. That takes care of rule number 2. The last rule has to do with when zeros appear to the right of a number. And the thing you have to be careful about is if there is a decimal point in the number. Like the number 12, written just like this, obviously has 2 places of accuracy. But if you add a point and then some zeros, there is a difference between 12 and 12.00. The difference is 12.00 has more places of accuracy. It is accurate to the nearest hundredth, whereas 12 is only accurate to the nearest ones. Last example, 5600 versus 5600, which is kind of tricky. This first one is 5600 without any decimal places, so the zeros that appear to the right are not improving the accuracy. This number is only accurate to 2 places of accuracy. It's been rounded to the thousands and to the hundreds. Now, 5600 with a decimal point, that decimal point becomes very important because that tells us this number has been rounded to the ones. So this measurement would have 4 significant figures. The questions that you're going to see about significant figures are, first one's very easy. It says, look at a measurement and how many significant figures does it have. In this case, 1.005 has 4 places of accuracy. It's accurate to the ones, the tenths, the hundreds, and the thousandths. The next type of problem you might see is round this number off, 41,235, so that it shows 1 place of accuracy, or 2 places of accuracy. Rounding this number off to 1 place of accuracy would mean that you're going to round off to this 1 place to the left, which is the 10,000ths place. So 41,235 rounded to 1 place will be 40,000. The digit behind the 4 is a 1, so I'm rounding down. And this measurement only has 1 place of accuracy now. If I wanted to round 41,235 to 2 places of accuracy, then my answer would be 41,200. Get rid of those zeros. 41,000 even. Okay, again, that would have 2 places of accuracy. The last one I have is an example of a kind of a tricky problem. Is if you have the number 42,951 and you want to round off to 3 places. Well, what you could do is look at the first place, the second place and the third place, and then you of course need to consider the digit behind. The digit behind is a 5, so that means I guess we're going to round up. So if I round up, it would be 43000, 43,000. But the problem is when you write down 43,000 like this anyway, there are two significant figures, and I told you that we were going to try to round this off to 3 places of accuracy. So that means that this 0 here is important, is accurate, although when it's written this way, it doesn't show any accuracy. The only way that you can do this problem to show the correct number of significant figures is to put the problem into scientific notation, or put the answer into scientific notation. And so the answer should be 4.30 times 10 to the 1, 2, 3, 4th place. Now that shows 43,000, but it also shows 43,000 measured to 3 places.